Hi, this recording is about calculating molarity and doing dilution calculations with molarity. So we use concentration a lot in the real world, in science. Obviously, these are applications of science. Like, for example, like if you've ever had your fasting blood sugar drawn, which probably you guys haven't, but as you get older, you do. They're looking for a value, a concentration in your blood of glucose of 100 milligrams per deciliter, or they even calculated in, I think this is millimoles per liter. So, and if it's above that, then it's not normal. And also, blood alcohol levels, those are concentrations, and they're in grams per 100 milliliters of blood. And then even, things that we're worried about in the environment, a lot of those are in parts per billion or parts per million. So lead, 15 parts of lead per billion is the cutoff. So if it's under that, it's acceptable. So, just lots of real life applications of concentration. So concentration is just really a measure of how much solute is in a solution. And we're going to be focusing in on molarity. So this is the one that's used in chemistry. And if you remember, it's been a long time since we've been in the classroom, but we did labs. Well, we didn't do enough, did we? But we did some labs, I think, where you would have seen the big M molarity on the bottle, and depending on the molarity, that, so anyways, the bigger the value, the more concentrated that solution is. So molarity is calculated by taking moles of solute divided by liters of solution. That's what you're calculating, but then your unit is also capital M for molarity. So it's actually just a way to abbreviate moles per liter. So you can choose either one when you're doing the unit. So if you have your mole map out, there'll be times, so we know that molarity is moles of solute per liter. So if we're concentrating on the mole here, sometimes you'll be given the gram and have to go to mole to be able to plug in, or it's possible in the question they're asking how many grams I would need. So you would have to solve for mole and then go convert back to grams. So here's an example problem where we would be calculating molarity of a solution, and this is one with ethanol. So it's 1 gram of ethanol in enough water. That'll give a total volume of 145 milliliters. So there's a few different little sub-calculations here. So we know that ultimately we want to calculate molarity, but we don't have the moles of the solute. We're going to have to convert that to moles, and then we also need the volume in liters, and we don't have that in liter. So we would want to do both of those before we go into the problem, or you could actually set the problem up where those are within it. But I'm just going to do it. I'm going to show you. It's been a while since we've done I think it's been a while since we've done a mole conversion. So going from gram to mole. Molar mass of ethanol is 46.068. I must have went to the thousandths with my hydrogen. So there's that many grams for every 1 mole of ethanol. So the grams cancel, and I end up with 0.0217 blah 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 moles, and I just keep it in my calculator and don't round till the end. And then the volume, the 145 milliliters, just a reminder, moving that to liters is just moving the decimal 3 places to the left. If you forget which way to go, you can also do it with dimensional analysis. You wouldn't have to show me this anymore, but there's 1,000 milliliters in a liter, so we know we're dividing, which would then give us 0.145 liter. So then I would just want to plug in my answer down here, my moles, my 0.0217 moles over my liters, my 0.145 milliliter, or sorry, I converted it to liter. So when I do that, and then I'm going to round it to, I think I should have 3 sigs, and I have to actually calculate it with you right now because I don't have 3 sig figs right now. So hold on 1 second. So it ends up with 3 sig figs being 0.150. And then the label, remember, it's moles per liter, but we can use a capital M. So that would be my answer. So the term concentrated and dilute, sometimes we use this. It's not quantitative, but it can still be something we use in our vocabulary. If something's concentrated, you have a lot of solute and a small amount of solvent. And then if it's dilute, you have less solute and more solvent. So there's times in chemistry as you go and take more courses where you will even do this, and it's things that I do also in the storeroom, is I make a dilute solution from a concentrated solution. So what I do is I take out a certain amount of the concentrated solution, put it into, these are called volumetric flasks. I think you get to use these in AP Chem. And then for sure, if you take college chemistry courses, they're really precise. They have a mark on them that tells you they're exactly, sometimes they're 100 milliliters or 1,000 milliliters, 500 mils. But so whatever amount you're making, you would add the concentrated and then add water up to that line to make another concentrated solution. So the math behind this is this equation where M1 is the stock solution or the concentrated solution. Stock is like the storeroom, what I bought in the catalog, that kind of thing. And then the volume of that, you're not going to need much of it. Then you would make a new, more dilute. M2 is the dilute, the one that we're going to use in the lab possibly, solution, that molarity, and then the volume of that, you're going to have a much greater volume. So let me just show you how to do a calculation with that. So here's an example. The volume of a 12 molar hydrochloric acid solution, what volume must be used? And this is a real life one. When I order the hydrochloric, it is a really concentrated solution. We actually have to order it like it's all packed in styrofoam and all these, we pay extra for safety. But anyways, so that would be your M1. So it comes that concentrated. And then they want to know how much of that I need to use. So I'm really looking for V1. And then I'm trying to make. So make is a keyword that tells me these are my 2s. So this is my M2 and this is my V2. So M2 is 0.25. I'm trying to make a much less concentrated solution. So I'm going to need, I'm going to make a lot of it too. Like maybe I'm making it for a lab or something. So here we plug in then to M1, V1, M2, V2. So 12 molar. And then I'm going to leave the V as my X, the V1. And then 0.25 molar times 7.5 liters. So then I would divide both sides by 12 molar. And then this goes, and then my units go, so I end up with liter. So V1 in this case is, what is it? It's 0.16 liter. So I'm only going to need a small amount of this really concentrated stock solution to make a big amount of this dilute, maybe my lab solution.